Hi today, Alex here. I woke up this morning and thought, you know what I'm going to do today? Make the dumbest program ever. Something even dumber than what I made last time. A program which increases this variable by 1 every millisecond, and then whenever I want to, I can have the program print out the current value anytime I want it to. So we need to make that. Let's try making that, shall we? So let's start by, we need a label so that we can continuously print out different numbers until we decide to quit, let's say. Then option 1, print number 2, or anything else. Stop. That'll do. And we need to just do that. Okay, and then we need a new variable so that we can store the user's option, and we can do all that. So now we can get the option. If we have option is equal to 1, then we'll simply see out the current value of the number. And then we'll need to go to option. Anything else we'll just leave. So let's try that out. And what should happen is we should be able to go like 1. Yep, and we can get the value at any moment we want, and then anything else just stops the program. So yeah, very simple program, nothing too complicated, very professional, totally pretty. So now that we have this program, we need to make this number increase every millisecond. Oh, well, that's pretty easy. Let's just go into option, I don't know, how about we put a while loop here, and we'll just say true, so it never ends. Never ending while loop, and then we'll just say number plus plus. Well, yeah, there we go. We'll just add to the number, and we want it every millisecond, so now it's time for a new thing called Windows.h. You can only do this on Windows. If you're using a Mac, you'll have to use a different command. You have to use a different include. Using this, I can use the sleep function, which takes in milliseconds. So I'll just put in 1 millisecond right there. If you want a second, that's 1,000 milliseconds. So this comes from this include statement. And now every millisecond number will increase. So let's test it out. Fantastic. You can't see anything, but in the background this code is constantly running. So let's try print out a number. Now why isn't that working? Well, it's simply because when we actually do all this, the program's just going to go from here to here, do this, wait, do this, wait, do this, just keep doing this over and over again for all of eternity. And the issue is we never get to this code, and so it never runs this code. The compiler never leaves, so it just always never gets here. So again, there's totally nothing down here. I'm just going to keep running this. So we need to fix that. But I still want the original code. But we can't have this while loop constantly running around and around in the same line of code because we still want this to run. Well, boy, do I have a fix for you. I'm just going to cut that out and then do the fix. We're going to need to use threads. So the way you can think about threads is like this. If you had, what a thread can do is that if you had like two functions, like say func1 and func2, what the thread will do is it will say, hey, while you're running function 1, you should also be running function 2. So at the same time. So we'll be running two functions at the exact same time. In the past, we can only run one function at the exact same time, but now we can run two functions. This is called technology. So now but how do we exactly run two functions? Well, first, the thread is actually going to be in a completely new include statement. So now we have 3 in this program. So you need to import thread like that. Now then, how do I use thread? Now thread can be used as a variable, so that's the variable name, like integer, int, or string, thread. We need a name, so I'll just call this num increase, best name ever. And then we need to put up some parentheses. Now, in these parentheses is what the function, this thread thing will continuously loop through. So what will be running at the same time this function is running? Whoa, technology, let's do that. We need a function, so I'll just call this inc. Best name in the world. Okay, so now in this we'll just copy and paste this code that we wrote last time earlier, and now we'll just put an inc right here, no parentheses. So now if I start running this, you can see that at the same time this function's running, I can also do this. So while this is always going to be running, as you saw last time, just continue running, I could just continue doing that. And it'll continue going like that for the rest of eternity. So fantastic. We've got a working program, right? Wrong. You see this? There's a problem we have. This thread never actually stops. So what happens is that because it never stops, when our program stops, the thread just and just absolutely explodes, and it just destroys all of our program, the entire program. So we need to stop this thread somehow. So how about I just create a new boolean called game over is equal to false. And then instead of true, we'll say while game over does not equal true. So while we're not doing game over, or the easier way you can do this, since it's a boolean, we can just say, well, if it's not true, if it's still false, continue doing that. And then maybe here we can say game over is equal to true. Yay, we did it, we solved everything. Now when the game over equals true, this inc will stop and the thread will be gone, done, and it won't explode and it won't go crazy, right? It still works like that. And at this point, the thread has stopped completely, because this game over is equal to true, so nothing else is in the function, so I shouldn't call anything else, right? Now why do we still get the error? Because the thread still exists. We haven't destroyed the thread, and we haven't even joined it with this real function. We haven't done anything. What the thread is doing in the background is that it actually creates a second compiler that you can think of it like that runs our inc function. Well, the first compiler runs main. When main terminates, you would expect that would mean the end of the program. The issue is this is still running in the background. This second compiler still exists. So when this is gone, the program ends, but the second compiler still exists. So that's bad. We don't want that happening, now do we? Because that'll throw an error, as there's still something and we didn't do a proper cleanup. In order to join, so we need to join the two compilers. To do this, we can say num increase dot join. And what this will do is when it reaches here, and if I use that analogy again, so if I just use com2 at inc and com1 at main, what this will do is that when we get hit here, the second compiler will then, when it's finished with the inc function that we made up here, it will join the first one, so now we only have one compiler. And when this terminates, there's no compilers left. And therefore, at the end of all this, no errors thrown, because there's nothing left and we've completely cleared everything out. And now you see we have a working program, and we have the world's most useless program Well, I mean, it could be used for tracking the number of milliseconds that passed, but who cares about that? And even if we quit, it's all completely fine, since we've joined the two compilers, and no longer are there any errors. So from this video, you should now know how to use the thread function, which is actually incredibly useful in making games and programs. And also, maybe you also learn the windows.h function and use this sleep just sleep function to wait a bit, just wait a millisecond. But yeah, that'll be all for today. Subscribe to me if you want to see more coding videos like this, and if you like this video and maybe learned something, you can press the like button, and I'll see you on the next video. Bye.